Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. Before I dive headlong into my next machine project, I'm going to check this little guy off my list right here. This is a naval deck gun. This is the kind of gun that you would see come sticking out of the side of Jack Sparrow's Black Pearl and blow away the competition when it comes to an open sea battle. This is one of those ones that was under deck and just rolled out when necessary. I do not have planers and shapers and all that stuff here for wood. So I'm going to do this like I'm cutting aluminum or some other metal. I'm going to make this out of mahogany. This is the project for today. So come along and let's see what happens. My wheels may be brass when I'm done. Maybe. I just have to see how that plays out. But I think a wooden carriage is going to look pretty good. And this is what it looks like modeled up. I'm going to go after the brown parts today, and I'm going to start with 1.5 inch slab of mahogany that I have laying around in the shop. Let's get to it. One of the unexpected challenges of doing this project was that wood chips, and I'm not accustomed to working with wood, so I had to be very careful which way the cutter was spinning and where my finished edges were. This did become a problem later on, and I think you'll like the solution. It's probably an obvious solution to you woodworker guys, but to me it was something that needed to be figured out, and it worked quite well. Squaring up the end of the block is when the chipping became apparent and forced the solution. And you'll see a chip here in a second. Right there in the front corner. Just devastated that edge. So a sandwich board is the way to go. Back it up with something and support the edge. This particular surface here will be the surface that has the ornate features cut into it. So there's no need to take the block all the way down. The block is finished size at this point. Using a form tool and a fly cutter head, I'll put those features on. Right there I'm zeroing out my x-axis so I know how far to come over, and naturally up it comes. You can see how effective that sandwich board's front and rear this time were for this operation. And yeah, I know the tool's a little bit deep right here. You'll see the secondary step on the leading edge of the radius when the tool is set to the proper depth. And that is because I am coming back at a later operation. You see the second step right there, the little hairy burr. I could probably sand that off, but why bother? I'm going to adjust the whole setup down just a little bit and come back across it and wipe that right off. Just knowing the radius of the cutter, of course, helps quite a bit. And make sure that your z-axis moves or your spindle drop incremental shifts or just a little bit less, and you won't have that edge that you need to sand off. In an honest attempt to keep the back sides of these pieces from blowing out, I've sandwiched this with some particle board, and I'm treating it like any other material. The chassis is inverted, and these are the notches where the square axles will sit at assembly. Now, if you haven't figured out exactly what I'm doing, I'm making the halves as one unit, and I will split this down the middle on the bandsaw and bring these to final thickness in the final operation. The half round cut between the front and rear axles is strictly cosmetic. It is a non-dimensional feature. And in this presentation right here, the way the wood is being put towards the cutter, if the wood is tilted forward or back, you'll see a taper here. So just adjust the setup accordingly. The fly cutter was set by eye. And look at how it looks like it's moving around right there. That is actually a camera illusion. I think the autofocus caused that. That is not moving. Do not attempt to adjust your TV. All right. Anyway, it is cosmetic, and I was going to two scribed lines on the block, and we'll take a look at the finished product here in a second. The notches in the top of the frame are for the trunnion on the cannon barrel, and this is the trunnion. These are the trunnion straps. And we're just going to sit the block in the mill, and we're going to chip away at that until this fits nicely down inside. I'm using a 4-flute 375 diameter end mill. That's about 10 millimeters. And I'm creeping it in from the side and oscillating it like that so it doesn't scream and burn and chatter. It gives it a little bit more shearing action, but I'm keeping the cutter engaged so I don't blow the bottom edge off of this block. Both of those outer faces are finished faces, and I would rather they stayed nice and sharp. I am going half the diameter of the cutter deep, plus a little bit, because I would like the trunnion to be free enough so that the barrel can flop back and forth for adjustment at assembly. That's a nice fit right there, but a couple more thousandths coming out of that, and it should do the trick just nice. Perfect. Cutting both halves of the cannon chassis from a solid block assures that they are identical, and it's probably a time saver as well. Always use a push block when you're working on a bandsaw, and you should go home with all your fingers. I'm going to grab the piece of mahogany that I originally started with and saw another chunk off. This block here will be done exactly the same way as the sides were, and that's a block for the axles. Getting there. The wheels will be fabricated from 1¼ inch diameter brass. It's about a 3.5 foot, 4 foot long bar, and it's not the same size as the hole through the spindle, so it will be oscillating and flopping around. That will translate to the finish and dimensions. If you're going to catch a piece like this while the machine is spinning, bear in mind that it's spinning towards you and could pinch your fingers between the part and the tool block, so be very aware of where everything is. Working with a shorter piece like that is much easier and friendlier. And we'll start with the facing operation. A very cosmetic cleanup cut on the OD is next. You can count on the stock having some deviations, maybe some scratches from people handling it in a manner that you wouldn't approve of. but a nice dust cut will clean it up. And a center drill and ream the inside holes before starting any of the face work. And brass is just such a pleasure to work with. And I've had people ask what the difference is in the RPM between the drilling and reaming operation. The reaming operation is usually half or less of the drilling RPM. With a small form tool, I'm going to put a miniature, a minimal, let's say that, a minimal recess in the front to make it look like a banded wheel. If this were in fact a wooden wheel, chances are it would have a metal strap around the outside, and that's just the visual I was looking for. And that feature will, at this time, only be on one side. The back side of this wheel is going to have a little recess, or excuse me, a little projection on it to keep it off the wood, or keep it away from the main frame, but it will be in contact with the wooden axle. Scotch-Brite, deburr the ID, and my favorite polish of all times, this Blue Magic polish is just fantastic. I love this stuff. And there you go, payday. That stuff is great. Check it out, Blue Magic metal polish, love it. I'm applying pressure to the outside edge of the parting tool to avoid some deflection of that tool until I get down to where I need to be. With the exception of using some sandwich blocks to avoid chipping, the preparation of the axle block is going to be done exactly the same way as the frame was. I'll bring it to thickness initially, then I will do the outside surfaces, split it, and then put in a square collet and finish off the rounds on the end. Stick around for that. That was a lot of fun. If you ever attempt to cut a block directly in half by eye, take a superficial cut, flip the part over, and if the blade enters the same slot, you'll know you're on center. I'm using a very hooked tool to turn this wood, and realized early on, you can see how it starts to helicopter out right there. So the plunge cut in the rear keeps that chip from going any farther than that plunge cut. As that material lifts, it'll stop at that shoulder and fall off cleanly and not blow up the block. If you were to make a cut like this without putting that relief in the back, chances are it would not end well. I like to have the sharp corners on the part that I'm doing, so I realized that early on was not a bad idea. Regardless of the material that you're cutting, it's always a good idea to keep a common surface in line with the feature on the collet. So the 5C marking on the face of the collet will always be in line with that same face on that wooden block. If for any reason that collet was not cut true initially, the axes or the center lines of these end features would not be in line with each other. They would not be coaxial. And if it was a precision part, that'd make a difference. But it's a good habit, so pay attention to that. Put a line on your part, glue up a piece that you're using, and put a dot on the face of your collet. Make sure everything stays in line. Now the following footage is taken from a full-length video that was posted a while back, and just to share with you the work it takes to do something like this. The center drill operation is just to support the material so it doesn't chatter with the large contact from this particular form tool. I'm doing a lot of this by eye based on the print, based on the visual. So I plunge it to a point where I like the amount of material left on the front. Now changing tools, this little guy right here is a tool that I use a lot. It's a 20-degree total, 20-degree included. And you need to look for the tangent point of the large radius versus the small radius. That's the only way this is going to work. All the movements that you are seeing right now are done with the compound. The carriage is locked. Do not move the carriage and do not move the setting that the cross slide is set to. That will give you the illusion that that taper passes through that ring that I just formed. If you must move the cross slide, make sure that you go back to the 0 point, and that will give you the exact same taper on both sides of whatever feature you're trying to create. And I think that this shot right here shows you that that taper looks like it passes through that ring. And if this was a real cannon, that ring would just be support so that the cannon didn't blow up when they lit the fuse. All the features that are supposed to be round are going to be blended in with a file and ultimately finished off with emery and some metal polish to take all the file marks out. Now, like I said, this is just a segment. The trunnion mount holes, the remainder of the barrel, all the other features will be shown in that video. So go check the video description link below and go to that video if you want to see exactly the amount of work it took to actually do this. We're going to move on to the cascabel, I believe it's called, the ball end of the barrel. And the neck, the minor diameter of the ball end was actually increased for this video because the first one failed miserably due to surface contact exceeding support material. Now watch this. Look at this material. This is just beautiful. Blue Magic metal polish. Love it. First thing I'm going to do here is to establish the shoulder distance on the end of the barrel. This is where the fuse would be lit. And this is strictly by eye. Now remember, the deeper you go with that tool, the farther that projected angle is going to go back. So you need to be real careful and put some kind of a witness material or mark or something on there so that you can see what's going on. And that's what the Sharpie was there. That's why that was put there. Now as you plunge here, you need to take the carriage away from the barrel so you don't dive in. And sorry for the lack of focus. There we go. Watch the black go away. Hey, just watch for it. Wait for it. There it is. Now this one right here, I am diving in with the front, diving in with the back, diving in with the front. I am not taking a full bite until the very last minute because I do not want to snap the neck of this material off. And I can promise you when that happens, that's one of those moments where you just want to edit out and fade to black. Now we're going to polish it up with the same blue metal polish, Blue Magic metal polish. I love this stuff. Some of my favorite stuff for 2022, no doubt. Well, that's about as far as I'm going to take it for today. It is just strictly sitting there. It is not fastened. And it was clever the way they designed this. All the hold downs for the trunnion straps go all the way through the frame and secure the cross axle to the sides. So it's going to be a long bolt that goes through here. The one that goes through the back here is going to have an eye bolt on it, but it cinches the entire assembly together, and then there's a couple that go on the side. Elevation on this gun is controlled by a wedge that goes in the back, so that as you drive the wedge in, it aims down, and that would be for shooting lifeboats, rowboats, and swimmers in the water. Outside this ship. Nice guys, right? Anyway, that's what it looks like. There will be pins on the outside, so the hardware on this is not complete yet, but it does roll real nice. Getting heavy too. That's a nice little piece. I like it. I think the model calls for wooden wheels, but I went with brass wheels just because I like the contrast. I hope you enjoyed what you've seen so far and tune in for the rest. Thank you very much for watching. This is Joe Pye at Advanced Innovations in Austin, Texas. I'm out. Yeah, just a little bonus clip here for anybody that saw the thumbnail and was saying, where'd you get the 50 caliber round? It's not a real round. It is actually a replica cut from 7/8 diameter brass. I figured I'd catch the very end of it just to prove that. Looks like a real one, but it is absolutely not functional. It's just for the thumbnail. I'll make a cool paperweight when I'm done.